Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on PVTP software, a very powerful and interesting software for compositional modeling, especially fluid modeling. All right. And in previous video, by the way, we are still dealing with, oil modeling, compositional oil modeling. And in previous video, we have completed or we have just checked this the current quality of matching for the CCE. And you can see this is the estimate generated from our current model, our current fluid model, whereas these are the data. This is still for CCE. So in this video, I'm going to focus on checking the quality for the matching for differential liberation experiment or differential liberation calculation. Okay, so to do that, I'm going to go to calculation, and here let's find the differential liberation, difflib, put it here. Okay, I'm going maybe focused or move them all like this. You can do that and scroll up, scroll down to make them bigger or smaller. Okay, so maybe I'm going to double click on this first. So here we have the input, differential liberation input. After calculation, we will have the results plot, results table, as well as detailed results. Okay, and before doing everything here, please note that by the nature of the differential liberation experiment, the composition of the fluid remaining in the container, container that we used in the experiment. Okay, so the composition of the fluid inside the container, the fluid remaining in the container will begin to change as the pressure is reduced below bubble point or saturation pressure, since the gas that evolved will be removed from the container, from the cell. As such, the residual oil volume, which is used to calculate the GOR and oil formation volume factor from the differential liberation experiment, will be path dependent. Okay, this is very important, this term, path dependent. Okay, or you can also say the conditions the fluid is exposed to over the course of the experiment will, will determine the GOR as well as the formation volume factor. If the conditions are different, the conditions under which the fluid is exposed over the course of the experiment, okay? So if the conditions are different, then the resulting GOR and the formation volume factor will be different as well, because it's path dependent, okay? And if slightly different temperatures and pressures are specified or whole stages are omitted, then the residual oil volume and thus the GOR, gas oil ratio, and the oil formation volume factor will be different. Therefore, we need to enter the exact pressure stage during, that were used during the difflib differential liberation experiment. Okay, so here we need to be careful in inputting pressure here, as well as the temperature here, because if you put slightly different temperature or different pressure, the GOR and the formation volume factor will be different, and it will reduce the quality for the matching. Okay. Okay, so here input model, user selected, but you can also use automatic. Okay, and today I'm going to use this user selected. This one will be 185. Click on OK. And I'm going to take the pressure beta from here. So enter lab data, deflip, and let's grab this data, copy. Remember this 185, right? And then, okay, go to deflip, and then just paste it here. Okay. So 4,000, 3,600, 3,200, 2,800, and so on and so forth. Okay. So now just press calculate. Done. You see now these are active, the results plot, table and detailed results. Here you go. So by the way, maybe we can check this sample first. Let's see what we have in the flip. So we have GOR, solution GOR, formation volume factor, as well as density. We will see the quality for those three. Okay, so click on OK. Currently, we are looking at the density. Okay, let me expand this. Okay, so here under results tab, results plot, we can see the quality of the match, For the oil density, generally speaking, okay, we can follow the trend. But for the exact value, we do not match at all. That's for density. The blue line are the estimation resulting from the model that we generate, whereas the symbols are for the data. So we need to improve the match for the oil density, okay? We need to significantly improve the quality for the match. All right. This is for the oil density. And we need to check as well for the data that we have. So let's go to oil GOR. Okay, also we need to improve the match. We can follow the trend, the general trend, but the results for the exact values are not very good. All right, and for this, the other parameter that we need to check is oil viscosity. Okay, maybe I can check it first. Differential liberation, oil formation volume factor. Okay. This one. All right, you can see we still need to improve the quality, right? We can follow the trend for the density, formation volume factor, and then, the GOR, but for the exact value, we need to improve the match. And you can also check that the results table here, you can copy to clipboard. Here we have including interfacial tension, gas viscosity, right? Relative volume, enthalpy, thermodynamic properties, entropy, Z factor. You have everything here, including the detailed results for each pressure, and the phase properties, the composition. You see below the bubble point pressure, the composition will be different. For liquid phase, vapor phase, as well as, the K values, the distribution between the vapor phase and liquid phase. That's the K values. But above the bubble point pressure, you only have liquid phase. You don't have vapor phase, and thus you also don't have K values. This is the temperature. Okay, so you can see we can follow the general trend for the three properties, the density, formation volume factor, and GOR. But regarding the exact value, the match is not very good. The matches are not very good. So that's our homework to improve. Okay, so I think we can close it. Still, we need to do another check. And the check that we will do after this video is the separator check. Here we already have the computation feature, and let's do the checking in the next video. So thank you so much. I hope this video is useful, interesting. I hope we can learn more in PVTP. And until then, see you, and again, thank you so much.